So in this video, we're going to look at some more power functions, and in particular, we're going to look at functions where the power is actually rational. So the number at the top here, this n, is a rational number. So power functions are actually what we refer to as monomial functions. Unlike polynomial functions, they have only one term in the function. And the value of the power, so the n value, impacts the shape of the graph of the function. And if the power is a fraction, if it's a rational number, if it's a fraction, then the value of the denominator and the numerator are going to determine the overall shape of the graph. So these are some of the power functions. All you need is x raised to the power of n, and n can be any number. So if n is a 0, we get f of x is equal to 1, and we refer to that as the constant function. If n is equal to 1, you just get f of x is equal to x, which is what we refer to as a linear function as well. We've also got the quadratic function, the cubic function, the hyperbola, the truncus. We can have fractions, some of which we've looked at already, so the square root function and the cube root function. So earlier in the year, in chapter 1, we looked at power functions already, and we looked at power functions where n was whole numbers, just integers, positive and negative integers. And we looked at them in different cases. So let's look first of all if n is positive. So we've got y is equal to x to the power of positive numbers here. So if n is odd, we're looking at something like this shape here, y equals x cubed, y equals x to the 5, y equals x to the 7. This gives us our cubic kind of shape. And some of the functions are y equals x cubed and y equals x to the power of 5. If our n is a positive number, but it's an even number, like 2 or 4, you get this parabolic shape. And this works for graphs like y equals x squared and y equals x to the power of 4. If our power is a negative number, like we've got y is equal to x to the negative n, if you like, then what we get is this 1 on x to the n, which gives us our two functions here, our hyperbola with its hyperbolic shape, and some of the formulas for that are y is equal to 1 on x, y is equal to 1 on x cubed, y is equal to 1 on x to the power of 5. And then our final shape is our truncus shape, where the two arms are on the top half. And equations, power functions that will give you that are 1 on x squared, 1 on x to the power of 4. So these functions can also be written with their negative powers, like I've got here. So for our hyperbola, we've got y is equal to x to the power of minus 1, minus 3, or minus 5. And for our truncus shape, we've got x to the power of minus 2 or x to the power of minus 4. So what I want to look at next is what happens to these functions and the shapes of the graph as n gets larger and larger. So how does increasing the size of the power in y is equal to x to the n change the shape of the graph? Well, let's have a look at the even numbered powers first. So on the graph, I've got the line y is equal to x, and have a look at the shape of the graph of these parabolas and see how they change as the power increases. So this is x squared to the power of 2, 4, 6, 8, and 50. So I hope that you notice that between 0 and 1, the graph was bending down this way towards the point 1, 0. And between 0 and minus 1 on the x-axis, the graph was bending down towards the point minus 1 and 0. For values that were greater than 1, what was actually happening was that the graph was bending up this way, approaching the line y is equal to 1, getting steeper and steeper. And on the left-hand side, the graph was also getting closer and closer, steeper and steeper, closer and closer to the line y is equal to -1. So we've got some definite patterns there. Let's have a look at what happens with the odd-numbered powers now. So you can see I've left our 2 points that were where our graphs were bending to and our 2 lines. So let's see what happens when we put in some odd-numbered powers. So we've got y equals x there. So this is x to the power of 3, x to the power of 5, x to the power of 7, and x to the power of 51, all odd numbers. And again, you can see the same pattern, even though the graph on this half, on the for negative x values, is in the negative y section, the pattern is still the same, the description is still the same. The curve is bending up towards -1, 0, and the graph is becoming steeper and steeper as you become more negative, and it's approaching the line y is equal to -1. And on the right hand side, it behaves in exactly the same manner. So let's put those patterns onto our graphs, onto our table of values from before. So you can see on both graphs I've added in the line x equals 1, x equals -1, and I've put in arrows indicating which way the section of the graph twists on the cubic shape and also on the parabola. So now let's have a look at hyperbolic and truncus graphs. So let's look at when n is a negative number. So here is the graph of y is equal to 1 on x, and you can see that I've already put in our 2 points from last time that our sections of the graph were moving towards. So I'm going to turn on the odd-numbered powers, negative powers now. So we've got x to the power of -1. This is x to the power of -3, -5, -7, and -51. You can see that the same kind of patterns are happening there. So you have the sections of the graph that are closest to the x-axis. So this section here and this section here approaching the 2 points again, 1, 0 and -1, 0. And the sections that are in between the x is -1 and x is 0, this time they're still moving back towards the line, but they're coming from the asymptotes that exist here, and they're getting closer and closer to x, the line x is equal to -1 and x is equal to -1. So let's add those to our table from before. So I've added the line x is equal to 1 and x is equal to -1 to both of the graphs, and I've drawn in the movement of each of the parts of the graph as n gets larger and larger. And so that's the patterns in the shape of the graph for whole numbers. Now we need to look at what happens when the numbers aren't whole numbers. The power is not a whole number but a fraction instead. So earlier in the year, in fact in chapter 1, we looked at functions that were also power functions where x was raised to the power of a unit function. So it's got a 1 on the top, they all had a 1 on the top. And we were just looking at positive values for z. So we looked at things like these graphs down here. Y is equal to x to the half, y is equal to x to the power of a quarter, y is equal to x to the power of a sixth. And for n values that are an even number, so the 2, the 4 and the 6, we get this square root shape here. And you can see I've got an included dot at the 0. And that's because our square root function has a restricted domain of 0 to positive values. You can only square root that has to be greater than or equal to 0. However, with a cube root, the domain is R, because you can take the cube root of minus 8 and get minus 2. If our function has an odd number as the denominator of the power, so like a 3, 5 or a 7, you get this cube root shaped function. And we call this bit, or we refer to this bit of the graph as its negative tail. So it has a negative tail, but the square root function doesn't have a negative tail. The other way that you will see these functions written, it may not have the power as 1 over 2. It may have it written in its root form, and they look like this. So we've got x to the half is the square root of x. You can actually write it with a little 2 there at the front, but it doesn't make much difference. We've also got x to the power of a quarter is the fourth root of x. The sixth root of x is 1/6. And you can see that the name of the power here, this is a third, so this is the third root of x. This is a fifth, so this is the fifth root of x. This is 1/7, so this is the seventh root of x. And so you might see the functions written like that. So again, we're going to look at what happens to the shape of these graphs as our n value approaches infinity, as our n value gets larger. So let's have a look at the patterns for y is equal to x to the power of 1 on n. So let's look first of all at even numbers for the denominator. So I've got the graph of x to the power of a half up there. So the next even numbered denominator is x to the power of a quarter. And you can see already that we've started to get some movement on the graph as well. So let's just keep a track of where those things are moving to and compare that to x to the 1 on 6, 1 on 8, 1 on 10. And again, you can see movement towards a point. This time, the point that we're moving towards is on the y-axis this way, and the line that we're moving towards is y is equal to 1. So all of the even numbered shape have that square root shape. So let's turn those off and let's have a look at the odd numbered denominated ones. So we'll start with x to the power of 1 on 3, 1 on 5, 1 on 7, and 1 on 9. And again, you can see that the curve is approaching this point, but you also have the same thing happening down in the lower half. It's approaching 0 minus 1, and also approaching the line y is equal to minus 1. So we'll add that to our table from before.